Well, good evening, everyone, and welcome back to the lab. Fresh off the truck, just out of the box, we have our next project. This is a Power Designs power supply. I'm seeing it, other than the eBay pictures, for the first time right now. It needs some help. This power supply is actually in pretty rough shape. The only thing I know about it right now is it's Power Designs. I have two other of their power supplies, and the two other power supplies I have actually regulate very, very well. So I was real happy to find this one. This one's a little bit unique in the ones that I found, and it's also going to add some capability to the lab. It's not just an extra power supply. This one goes to from 1 to 100 volts DC at 0 to 1 amp. So this will do 100 volts, 1 amp. Looking forward to getting this onto the bench after I do a restoration on this, getting it back on the bench. Having it the 100 volts will actually be real nice because this is the one power supply I found that'll be able to charge the battery stacks for some of the UPSs and things that I work on, because those go up to 72 volts. So my little 25 volters that are back here, actually, there are the two other ones back there. There we go. There are the two other power supplies back there. I very much recommend the B versus the A if you're going to use it as a power supply or work with op amps. There's a very useful difference between the two, which I'll go into a little bit later in the video. Actually, let me just move this here for you real quick. So the main difference between the two is source A and B on that one has 2 posts each. On the A version, they're combined. So the positive here is the same as the DC, even if you're trying to use the supplies independently. So that is difficult. That can be difficult to work on when you're trying to not use the tracking supply and you're trying to use it as a split supply. So if you're looking for one, the TP343B is definitely the one that's more desirable to have. This one, on the other hand, is what even is this one for model wise? Oh, it's a 1010T. The T is for transistorized. Got a funny little transistor man there. So haven't even turned this thing on yet. Don't even know if the fuses are good. This is in real rough shape. Oh, it's heavy. So this particular unit's in real rough shape. So what I'm going to do is I'm going to get this off. I'm going to start working on cleaning this up. And then when I open this up, I'll actually bring you guys back and we'll take a look at it on the inside. The only clue I've got to what might be going on the inside for this thing, it's even missing 3 of the feet. That's why it's uneven on the workbench. So we'll address that when the time comes. This feels like it's adjusting a variac inside. So I'm not sure if that's the way they've implemented this, where it's a variac into a rectifier and that's how they're doing the voltage, and then they're just doing fine regulation over here. Don't know yet because I haven't even taken the covers off yet, but this feels, the way the control feels, it feels very close to turning a variac. So we'll see what that looks like when we get it all open. But for now, I'm going to get started cleaning this up. And then once I have this cleaned up, I'll bring you guys back. Okay, and we're back in the lab after an extensive cleaning of the front of this. I think it looks infinitely better than it did before. Cleaning out the knurling in the knobs took a bit. Had to hit it with a scrub brush, let it soak in alcohol for a little while, pick them out with toothpicks, things like that. The front of the case just cleaned up with alcohol. I don't know what that black stuff was that was on it, but the alcohol softened it up, and with a spudger tool I was able to just scratch it off and not mar up the aluminum. What I was using to clean it up was, I was actually using a plastic tool. So I was scraping at it with a plastic tool so I wouldn't scratch up this brushed aluminum. Once you get a deep scratch in here, like here's a couple of scratches in here. Once you get a deep scratch, it's noticeable forever, and it's very, very hard to get out without resurfacing the whole front of the unit. The paint on here was not susceptible to alcohol at all. The alcohol didn't even touch it, so it was great. I didn't use anything harsher than isopropyl alcohol on it, so I didn't have to risk any of the paint. Everything was good. So the case, when I get it put back on, it still looks pretty gross and it's kind of rusted, so I do want to refinish the case of this at some point. I do need a sandblaster so I can sandblast the case out. At the current time, I don't have an air compressor big enough for a sandblaster, and I don't have a sandblaster itself, so I'm gonna have to wait on the case. But it did clean up. I washed the case with some Simple Green, and scrubbed it off real good. And then I also did some alcohol on the case to get all the big chunks off. So before I turn it on and give this thing a test, I figured we'd take a look at the inside. In the beginning of the video, I said this felt like a Variac. Turns out that is correct. So if we take a look at the business side of this, this is what it looks like inside, and one of the reasons why it's so heavy. Big transformer here. This is the main power transformer. The Variac itself is right there. If I move the knob on the front, you can see the wiper moving in the back. That's the main voltage adjust. This pot right here is for the fine voltage adjust, which actually adjusts, I believe, I don't know how much it adjusts yet. So we'll take a look. Not sure about some of these capacitors. They look like they may be past their fresh date. So we're going to fire it up and just see how it's regulating. We're going to let it warm up for a little while and just see if we have any problems. One thing I do notice is, so the way this is working is Variac into a diode stack. I was like, well, here's diode, there's diode, a couple more diodes. I'm like, but they're kind of small. These are the bridge rectifiers for the main supply. So if I turn this way, this thing is heavy. These are the main these are the main rectifier diodes for the supply. You can also see the backside of the Variac here. There's the wiper moving as it turns. It actually moves very well. A little bit of I'll put a little bit of oil on the front, but other than that, it's great. No problems whatsoever there. Now I'm looking at this unit, and given that this is a rectified, filtered, and regulated DC supply, I'm expecting to see some pretty big capacitors somewhere, especially since we're up at 100 volts at 1 amp. Obviously, nothing on this board is big enough for that. So I was wondering where the main caps were. They're actually, God, this thing's heavy. On the bottom, here are the main filters for the supply. So those caps are huge. They are 980 microfarad at 200 working volts DC. We'll have to see if these are good. We'll put a load on it, see how well see what kind of ripple we get out of it. We shouldn't get any, but we'll do a ripple test on this under load. I'll have to figure out some resistor values and probably get a decent sized resistor, because I'm not sure I have a 1,000 watt resistor, because 100 volts, or no, sorry. No, 100 volts at 1 amp is 100 watts. So I'll need a 100 watt resistor for that to get that into the current range. The regulating transistors, due to the fact we have a transistor man right here and a transistorized supply, the main regulating transistors are on this other side. Here are these big guys. So these are the pass elements. Nice big aluminum heatsink on the side of this thing. Oh, there's a little bit more junk on these power resistors in the back. Got to clean a little bit more off before I put it back in the case. So we'll get some cleaner here real quick. 9%. Oh, I have run into something for those of you who might be new to the hobby. So there's two main types of alcohol. We have rubbing alcohol. We have technician grade alcohol. I'm not sponsored by either of these companies. Covered that one up because it's regional. The technician grade isopropyl alcohol is 99.9% pure. The alcohol that you find at the grocery store is mixed with pure alcohol and deionized water. However, because of tax issues in the U.S., there's a bitterant added to the store-bought rubbing alcohol to keep people from drinking it. It's not good to drink it to begin with. This is not ethyl alcohol, which is made from grains. This is isopropyl alcohol, not to be confused with methyl alcohol, which is wood alcohol, which should not be consumed under any circumstances as it is toxic and poisonous. So for cleaning things, the alcohol will flash off and it'll evaporate and it'll do what it's supposed to do, but it'll leave the bitterant behind. So if you're cleaning switches, things like that, you should not be using the store-bought rubbing alcohol. Doesn't say it on the label. Yeah, it's not labeled at all because all it says is active ingredient isopropyl alcohol 70%, and then inactive ingredient water. There is a bitterant in this. I know for a fact there's a bitterant in this because I used it to sterilize a thermometer, and then when I used the thermometer, it tasted horrible. So the drugstore alcohol is not the same thing as technician grade or reagent grade alcohol. There is a little bit of extra something in here that is not on the label that you don't necessarily want in controls and switches. For washing down a case or something like that, who cares? But it's just not the same stuff. So if you want a 70% isopropyl alcohol, the best thing to do is start with technician grade of some form and dilute it down with deionized water. Don't use tap water because tap water has impurities which are conductive. But dilute it down with DI water to whatever ratio you want, 70%, 60%, whatever. You just have to dilute it down. Under no circumstances should anybody be drinking any of this stuff. Don't do it. In this bottle is this stuff. In this bottle, I actually have to wash this out because I ended up putting drugstore rubbing alcohol in it. So I have to wash this out, and then I'll mix up some other isopropyl alcohol with DI, and then I'll have 70% that doesn't have the bitterant in it. But as of right now, that has the bitterant in it. So just letting you guys know some stuff that I've found out recently. But we'll just clean off this extra. The other thing I like about these bottles is you push down on the top and it's a pump. So it'll pump up into the well at the top a little bit of the whatever's in the bottle, whether it's acetone. I have some glass bottles that I store acetone in, and yeah, if you don't like the plastic bottles, I just like that plastic bottle because it's labeled. But I also have some glass, same pump top, but glass bottle with acetone. But the thing that's great about these pumps is it doesn't I can just do this in the lid, and even though that's dirty, it won't contaminate what's in the bottom of the container. So that it's wonderful. Now the device is off, everything's unplugged, so I don't have to worry about anything like that. We're just going to clean up some of the crud. Ow. Now, one of the reasons, I don't know if I've mentioned this yet, but one of the reasons I was interested in this power supply was it was not expensive for what it was, and I needed to work on some of these UPSs. I needed some higher voltage power supplies because some of these UPS batteries are 72 volts. And that's way too high for my other power supplies that are back that way. The two triple power supply, or the two triple outputs, they only go up to 25, and the Rigel only goes up to 30. So if I try to plug a 72 volt battery pack into those, we'll overload those and blow them up. Also, I don't recommend charging batteries with the Rigol power supply. Older units seem to be much more tolerant of it, but if you wire a battery backwards, I think even Dave Jones did it of the EEV blog. If you wire a battery backwards on the Rigol, you actually blow up the input. So, and I do not know how much that costs to fix. Even more crusty. All right, let me get some paper towel and do a wipe down real quick. Okay, there we go. That was just on these resistors and this surface right here, and a little bit down here on this ledge. So there's some junk on there. So what I will do is I will get the power analyzer in the shot, get this alcohol put away, and then we'll start this up, see what kind of current draws on it, and hopefully nothing smokes out. And then we'll just let it run and see how well it regulates and if we need to align it. Okay, we have the power analyzer in the shot. We got 122 volts, which is, it's not hooked up to the current limited supply. So this is straight into the mains. So actually mains is running a little hot today at 22 volts RMS. No current, no watts because it's not on yet. So what I will do is we'll just flip this on and see if any excitement happens. Oh, we have a light, 7.5-ish watts at so 94 milliamps for AC, no load, but these are both down. Good so far. Let me get the meter set up. 10 power line cycles just so we can see it quickly. And we're on DC volts. So what we will do, need some banana jacks. Get some leads that'll work. DC up. Okay. That's not going to work. Those are not regular 4mm banana plugs, it doesn't look like. Oh no, the connector came apart. No, what happened was the backside of the connector came out. So let me fix that real quick. We'll see if we can get these to work again. Oh, yeah, they just don't go in very far. Okay, so we are actually pretty accurate. So the power supply says it's from 1 volts to 100 volts. And if we go up to the meter, we're at 0.984. So everything looks good there. So what we'll do is, let's see if we can set 50 volts right in the middle. Looks like 50 volts. What do we have? 50.16. So that's pretty bang on, actually. Let's try 75. Actually, let's go down. Let's go down to 30. Too far? $29.8. So on a 100-volt supply, we're off by 140 millivolts. Let's go up to 70. $69.5. Now I'm off to the side. The camera's straight on, but the unit is tilted at a slight angle. So looks like. So let me get straight onto that. Yeah, that's right on the 90. So 89.9. So that is regulating very, very well. So what I'm going to do is let me get the case back out, let this discharge a little bit, bleed those massive capacitors off before I touch it, and then I'm going to I'll throw this back in the case, and then I'm just going to leave it on and see if anything happens. We'll just give it a burn down test, see if there's any excitement. There wasn't any when I turned it on, so I think we have a fully functional power supply. I'll have to see if I can pull up see if there is an alignment for it. I don't even know if there is. So let me get it back in the case, and this guy may be ready for the bench. Okay, I got it back in the case and everything in the shot. One of the reasons why I wanted to do this test with it back in the case was I did want this to generate some heat just to see if anything got too warm and wanted to go away. As you can see, we have 89.9 volts. We're set to 90 units drawing 11 watts. So real comfortable. I don't have any problems with any of this. I also wanted to get it back in the case because in the lab we have a cat, and she likes to hop. I keep her off the bench, but every once in a while she hops up here when I'm not looking and likes to sniff things. And with all the power components in here, I didn't want her sticking her head in it and bad things happening. So all I got left to do on this one really is just let it sit here and cook for a while. I'll leave this on for a couple of hours, let the meter, actually we'll reset. We'll clear the active buffer. I didn't say this before, but I am not sponsored in any way by MG Chemicals. I just use some of their products because I have found them to be high quality products. No sponsorship there. They don't pay me for saying that. It's just what I use in the lab. So what I'll do is we'll make this. We'll just tweak this up to be 90 itself. There we go. A little too much. Okay, we are at 90.065 volts. 4, 3. Yeah, it's regulating. So we're at 90.02. We'll leave it there. I'll reset these metrics, and I'm gonna just let it run and see what happens. I'll bring you guys back after it's run for a while. You guys will know, because if you look up at the readings, the way I have this set, actually let me make this as sensitive as possible. We'll hit filter and 15. So now it's taking a reading every 15 power line cycles, but because the filter is applied, it is reading that it's only posting every 150 readings because it's 15 power line cycles and then multiply by 10 to average it out. So what we will do is I'll do a ripple test also, but for right now we'll just leave this set up we'll let it cook, and we'll see what happens. And you guys will know there's no trickery in the lab or anything like that, because when I come back, that readings number will be high, and you can see, I'll just keep talking as it's ramping up. You can see how slowly it's adding readings. So when I come back and there's a couple of hundred readings, it's cooked for a while. So we got 2 more, and then we'll be right at 10 readings. But that's the most sensitive I can, or the most accurate I can put that meter is with the filtering and the averaging, because then it's filtering out the noise and things like that, and a few other things. So yeah, we just hit 11 readings as I've been talking. So I'll let that run, and we'll see what happens. I'll keep the power phase meter, or the PM100 on it, just so I can watch it, make sure it doesn't do anything crazy, like all of a sudden start drawing 200 watts. But I'm sure if that happens, the 2 amp fuse that's down here will go away. So yeah, let me just let that cook, and then we'll go from there. Like I said, it's not the prettiest unit yet because I haven't repainted the case, but I need a media blaster to do that. So that will be next on the list. Well, I will just let this burn in, and then I'll be back in a while. Okay, I'll zoom in here on the meter here in a minute. I've had this running for most of the day. Also, this is the next day. I've had it running most of the day yesterday as well. Had it set to 90 volts. I don't feel anything. Nothing is excessively warm. Everything is working well. Power supply is still only drawing 11 watts. So, actually, line voltage is a little light today. Everything looks good. I've had the meter running with it set to 90 volts since this morning. We'll zoom in on the meter, take a look at how the performance was. So, focus. There we go. Obviously no trickery. This is set to filtering and 10 power line cycles. So you can see up here how long it takes to make a measurement. So we've just taken a measurement. We've just taken another measurement. We just take another measurement. So that's how long it's taking to increment this number. So we have had 7,405 measurements at this time, with an average voltage of 90.05. I have it set to 90 volts. So the maximum it got up to was 90.09. The minimum it got down to was 89.99. So we have 100 millivolts peak to peak regulation on a 100 volt supply. So that's well within, if I'm pushing 100 volts into something, it's not going to care if it gets 100 plus or minus 100 millivolts. Standard deviation over that time period was only 23 millivolts, so it's actually regulating very well. We can see that if I blow the graph up. So just to get scale, this is 90.0, this is 90.1. So it's slowly drifted up throughout the day, and this is a measurement period of 6 hours and 40 minutes. So it's slowly climbing, but having it on, that is not a big deal since it's from 90 to 0.1 to 90.1. So this power supply is regulating just fine. Everything looks good with it. I will pull this back out real quick. I'll take a look at it. Power supply looks good. The face cleaned up real nice. I'm real happy with it. Like I said, I don't have a sandblaster yet, so I can't clean the case, but I'll do that eventually. So I'm going to put a lid on this one. I was hoping to have a power supply to fix, but these Power Design power supplies are, for their age, they are incredibly rugged. This thing still works real well. So we had a tour of a 100 volt power supply. This is going to go on the bench, and we'll see if we can get into the next project. So thanks for swinging by the lab. If you guys have any questions, comments, like to see me do a video on something, leave a comment in any of my videos. I do read all the comments. So anybody has any questions, just feel free to ask. And we'll see you in the next video.